Good morning, year six. Right, guys. Today we're going to start doing these little recap videos twice a week. So, in addition to the bigger maths video that you get on your posted out section, where you have somebody much, I don't know, much more used to having their voice recorded than me, speaking to you about your new learning. I'm also going to revisit an element of your learning that might have been missed in year five, or we might just need to go over a little bit based on my teaching of you this year and what I think you need a bit of extra help with. These will come out on Tuesday and Friday. You don't need to do printed worksheets for these, but like Nathan's been brilliantly doing, if you could just have a go at working through the examples, you will get the answers within the video, but it's just to ensure that any little gaps which might have appeared because of previous lockdowns are squidged back together and filled in nicely. Okay. So having to think then, we're thinking about volume in relation to shape today, not in relation to sound. We're thinking about volume in relation to shape. Understand it? We need to understand what volume represents is how big, what the capacity of a shape might be. We clarify the elements we need to make calculations to identify the volume of something, and then we're going to complete some calculations relating to that. Okay. So to identify the volume of a shape. I want you to think about what you need. And then I'd like you to think about if you had 10 little cubes, and I know you probably don't unless you're really lucky and get to do lots of building at home. If you had 10 little cubes, what little shapes could you make? What shapes could you make? And if you do have some cubes, could you try and make some? So maybe sugar cubes, or if you have some little square blocks, what different shapes could you make that have all got the same volume because you're all making them out of the same size cubes? Pause the video while you think about that. Okay, and then we'll carry on. So we need the length, width, and the height of a shape. Okay, so we can't just, if we were identifying the volume of, say, this box, this cuboid box, we need the length, so how high it is from one, so how long it is from one side to another. We need the width, so from front to back. I'm doing this badly on the camera. So the length, then, I'm not used to filming, so the length is from there to there. The width is from there to there, and the height is from there to there. Okay, so those three measurements, when we have those, we can calculate the volume. Now, if we had 10 cubes, we might just go for this first one where we've got 2 high, 5 along. We might go for 3 high, 3 high, 3 high, and then 1, because we've got those 10. We might go for 2, then 3, then 3, then 2. We might go for 2, then 4, then 4. There's lots of different ways of doing it, but all of these have the same volume. Now, some of them, it will be challenging to calculate as a simple multiplication due to the fact that they're different heights or different widths at different points within the shape. The first one, however, we could quite easily calculate because it's 5 multiplied by 1 multiplied by 2. So 5 times 1 is 5, multiplied by 2 is 10. So we know that volume is 10. And we know all of them have got the volume of 10 because they've all got 10 cubes. But the only one, if we were just given the data that we could calculate easily, is that first one, because it's the regular 2D shape at the front of the as the face of the 3D shape. Okay, guys, let's have a look at this STEM sentence then. The cuboid is made up of 1 centimeter cubes. And the second sentence is the volume of the cuboid is centimeters cubed. And you can see there the little 3 after the M in centimeters, and that 3 shows it's the measurement of volume because it's length times width times height. It's 3 measurements, and therefore we understand it to be a 3 just to the right of the M of centimeters. So can you try and fill in these sentences? So for the cuboid is made up of how many 1 centimeter cubes? And I've got to tell you it's not 10, although you can see 10 on the top. There's two layers, and therefore what's the volume of it? Well, if I know it's 10 and 10, that's going to be, well done, 20 centimeters cubes, and therefore the volume is 20 centimeters cubed. Okay, guys, looking at A and B, can you work out what their volumes are? And I'll tell you, obviously, that the cubes here are always 1 centimeter cubed on their own as their volume. Okay, so what's A, what's B? Looking at it, looking at the length, the width, and the height, what can you identify the volume of these two 3D shapes are, please? Well done if you've spotted the first one is 4 times 4 times 1, which is 16. And then the second one is 2 times 6 times 2, so 2 times 6 is 12, times 2 is 24. Well done if you spotted those two guys. Okay, next ones, guys, we'll have a look. As I say, the capacity, so how much space is taken up within a 3D shape, is the volume. So here, our volume is measured within centimeters cubed as a liquid. Okay, so which one is 600 centimeters cubed, which one is 50 centimeters cubed, and which one is 400 centimeters cubed? So here we've got to convert from milliliters to centimeters cubed. See if we were able to identify that. Hopefully we are, because we see that 50 milliliters is the equivalent to 50 centimeters cubed. So 1 centimeter cubed is the same as 1 milliliter. 400 centimeters cubed is A, and 600 centimeters cubed or 600 milliliters is B. Okay. True or false? Is a cuboid's volume 20 centimeters cubed? What do we think? Pause it while you think. Give you a clue. It's false. Oh, I thought it was going to be one of those seconds. Guys, if you've managed to do that without my helping, great. If you got a bit of extra help there, wow, you squished through an extra question nice and quickly. Good job. Okay, guys, we're going to do a couple of sheets on this now. What we'll do, I'll show you the sheet. You write your sheet answers on your piece of paper and then you mark them yourselves. It's just to recap prior learning. So here, we've got some volumes and some cups. So which volume relates to which cup for 7A and 7B, and then a true or false question for our green and our yellow 3D shapes. So pause the video here while you work through those, please. You don't need to draw anything. I know some of you, Aksa, Farouk, and some of you, Annalie, have been doing fantastic diagrams, and you as well, Umaima. But you don't need to draw anything. It's just writing the correct value next to the correct number for A and B, and then writing whether it's true or false for A and 8A and 8B. So looking now, 7A, we've got 7A. So A is 50 centimeters cubed because 50 milliliters is the same as that. 400 centimeters cubed for B and 70 centimeters cubed for C. Move Mr. Spring's face out of the way so we can look at the answers for 7B. 300 centimeters cubed for 300 milliliters. B is 10 centimeters cubed because it's 10 milliliters, and C is 900 centimeters cubed because it's 900 milliliters. True or false? It's false because it's 10 times 2 times 2. It's 5 times 2 times 2. So 5 times 2 is 10. 10 times 2 is 20. It's false because it's 3 times 3, which is 9 times 2. So 3 times 3, 9 times 2, which is 18. Okay. Guys, again here, pause it. Write these STEM sentences for 9A and 9B. And then for 10A and 10B, if you could work through those as well, please. Right, guys, have a look here. So this we can see for 9A, it is made up of 23 centimeters cubed, and consequently, its volume is 23 centimeters cubed. B is 22 and 22 centimeters cubed. 10A is 10 centimeters cubed and 14 centimeters cubed for B. 10A B, and then 10B is 18 centimeters cubed and 14 centimeters cubed. So well done for working through those. Hope you get on all right with your percentages work as well in the other section of the lesson today. And then we'll keep going through these recap videos on Tuesday and Friday. Look forward to seeing you tomorrow's Zoom. Thank you very much for your efforts today, and I'll speak to you all soon, guys.